Hey guys, pre-test for solving systems. This is question number 4, and I've gotten a little bit of a head start on this one. Just to show you a couple of key features here. The first thing is you want to notice that these two lines here meet, as we would expect. We're trying to find that intersection, but they meet with that little box, and that little box should remind you that those two lines, line 1 and line 2, as I've called them, I called this one line 1 and I called this one line 2, are perpendicular to each other. They do tell me up here that line 1 and line 2 meet at 90 degrees, and that's code for a perpendicular line, and so we remember about that on perpendicular lines, that the perpendicular slope is equal to -1 divided by the original slope. So the question then becomes, well, which slope are we going to find first, and which equation are we going to find first? I called this one equation number 1 because we have 2 points in equation number 1. And let me back up. I should tell you too. The second you see any of those intercepts that are only partially labeled, as yours originally were, we go ahead and we fill in the rest of those numbers. So this isn't just 60, it's 0, 60, 0, 22.3, and 24, 0 for the x-intercept over here. So with these 2 points, of course, we know that we can calculate an A. And we can also calculate the B. Now you might realize that this is the B for this line 1. That is the y-intercept. And over here, this is the B for line 2. And you can read them right off the graph. When you know the x is 0, that tells you the B. But you could also solve that algebraically in case you've forgotten. So I'll show you how I did that over here. First thing I wrote is I wrote out the two general forms that I'm trying to find for line 1 and for line 2. Just as a reminder, we're looking for y is equal to ax plus b. And I wrote down my slope formula, y2 minus 1, y1 over x2 minus x1. And so for line 1, I went y2, 0 minus 60 over 24 minus 0. y2 minus y1 over x2 minus x1, right over here, which gave me a -2.5 for my slope. So the equation of this line here has a slope of -2.5. Now let's say for a moment that you forgot that the b was 60. How could you go ahead and get it? Well, you have an a, it's -2.5. And if you look at point 1, you have an x and a y, a 0 and a 60. X is 0 and y is 60. So you could plug those points in, the a, the x, and the y, into the general rule of y is equal to ax plus b, and solve for b. 60, y, is equal to -2.5. That's your a. X is 0 plus b. 60 is equal to 0 plus b, and of course 0 plus b is b, leaving you with a b of 60. So the equation of this line then is y is equal to a, -2.5, x, plus 60. Make sure you take a second and you write out the whole equation, okay? Because without the whole equation, you can't do what you really need to do, which is to solve that system. For the second line, y is equal to ax plus b right over here, line number 2, which I called this one, we only have 1 point there. We don't have 2, so we can't calculate the slope. And that's why it's important that we know that this is perpendicular, because without that perpendicular sign, we'd be stuck. We'd never be able to get the equation of this line with just 1 point. But we can figure out the slope of this line because we know that the negative reciprocal slope, -1 divided by the original slope of -2.5, will give me a positive 0.4. Okay, so I went -1 divided by the original slope, giving me the new perpendicular slope. And we know the b, it's right over here, which we could find algebraically if we had to, like we did over here. And that's going to be y is equal to 0.4x plus 22.3. And so that equation is for line number 2, right over there. So that means if I take this equation and this equation, I now am looking at a situation exactly like the other question. So I have 2 full-blown equations, and now I just have to solve for x. So I've done that down here. I took the right-hand side of the first equation, y is equal to -2.5x plus 60, as it existed up here, that right-hand side, and I made it equal to the right-hand side over here, 0.4x plus 22.3. It's always the same thing. Puts everything in terms of x's. I subtracted 0.4x from both sides, leaving me with -2.9x plus 60 is equal to 22.3, and then subtracted 60 from both sides, leaving me with 2.9x is equal to -37.7, and then did the division, leaving me with an x of 13. So at the bottom here, I can tell you that the x is 13, which on the graph means that x excuse me, is 13. And we're looking for that matching y still at that point. So we have to find y. And the way we find y, once again, is to plug that known x into one of the 2 equations that we learned previously. So y is equal to negative 2.5 x plus 60. We're going to put that x of 13 in there, negative 2.5 times 13 plus 60. So y is equal to, now you can do this all in one shot on your calculator, 2.5 negative times 13 is equal to that, plus 60 is equal to 27.5. Not a pretty number, but that's the right number. So just think about what that means, right? That the x is 13 and the y is 27.5. Now let's say you want to be sure. Well, once again, we can check. We can check y in the other equation, because y is equal to 0.4x plus 22.3. And so y will be equal to 0.4 times 13 plus 22, 0.3. Clear it up. Here we go. 0.4 times 13 is equal to that, plus 22.3. Hey, and there you go, 27.5. So we have verified that those two y's are the same when the x is 13, which means we now know our answer for sure of that location is 13 for the x and 27.5 for the y. Big thing here to remember is that those perpendicular lines allow us to get that second equation because of the negative reciprocal slope. One more to go.